guys. We are in section 11.4, looking at dividing rational expressions. The nice thing about the YouTube videos is that at any point in time, if you need to stop to write something down, you can do that. Or stop and try to do the problem before me, or go back and try to do them and then check how you're doing. So there are some benefits to having the video, and then you can replay it as many times as you need to, just to hear the sound of my voice and all of those things that I know that you miss so much not being in class with me. So we did multiplying in 11.3. Remember, dividing is just like multiplying, except we have to flip the second number, and then we just multiply like normal when we're using a fraction. So if I have a over b divided by c over d, that's the same as a over b times d over c. So all I do is change this to multiplication and flip my fraction. The trick is that if at any point something is in the denominator before the end of the problem, and it either is moved from the place of the denominator or canceled from the denominator, then it needs to be an excluded value if it's a variable. So if it's just a number, it doesn't matter. But if it's a variable, it matters. So if you look at this problem, like b and d can't be 0 because they're both in the denominator. But because I flip it, c also can't be 0. Because otherwise I wouldn't be able to flip that fraction. So if this were my final answer, because I can't simplify that anymore, I would simply need to say that d can't be 0. Because it's obvious that b and c can't be. But I would need to specify that d can't be 0 because at one point it was in the denominator and it's not anymore. And nobody can tell that by looking at it. So we'll look at some examples and see what that's like. So that's really the extra trick here, is flipping your second fraction and then remembering that your denominator can never be 0. That's really important. Okay, so here's this problem, kind of like last time, starting out a little simpler. And if I rewrite that, so I'm going to rewrite my first fraction the exact same way, change it to multiplication, and then I flip this second one. I need to make a note off to the side that c cannot be 0. That's what I would do, just because that helps me, because I just did it, and now I don't have to worry about it anymore. Okay, and then I can cancel things, because now I'm just multiplying. So c divided by c is 1, and a cubed divided by a leaves me with a squared, and that a cancels. So I canceled the a over the a. So I'm left with 5a squared b divided by 4. And what is the other thing that we need to put on our excluded? Look here, a. I canceled that. So a also cannot equal 0. So all together, this is my answer with both of those parts. Okay. Okay, this one gets a little bit more complicated. So I'm going to rewrite it. And some of you may be able to skip some of these steps after you get going. But right now I'm just going to go simply, and I'm going to just flip that second one and rewrite it. It saves me from making mistakes. If I try not to do too many things at once, I'm going to make fewer mistakes. Let me rewrite that. Okay. So now I'm going to factor. I have the difference of 2 squares, so that's x plus 3 times x minus 3 over x plus 1 times, here I can factor out a 2. So I have an x minus 3. And then in the denominator, what do I multiply to get 3 and add to get 4? Well, there's only one way to multiply to get 3. 3 times 1, and 3 times 1 is 4. So I have x plus 3 times x plus 1. This would be a good point where I look back and I think, okay, this was in the denominator at the beginning, and it's gone now. That's not there anymore. It's up here. So I want to make sure that I say for my answer that x cannot equal 3. Because 2 times 3 would be 6, and 6 minus 6 would be 0. And this can't equal 0, because that's bad. Okay. Now I will cancel, and there isn't a lot to cancel. I can cancel the x plus 3's. And that is it. And because I did that, x also cannot equal negative 3. Because if I have a negative 3 here, that would make that 0. And I can't have that be 0. So now I'm left with 2 times x minus 3 times x minus 3. So I'm going to write that as x minus 3 squared over x plus 1 times x plus 1, which is x plus 1 squared. And so this ends up being my answer. That 2 times x minus 3 quantity squared over x plus 1 quantity squared is my answer, and then also that these are my excluded values, 3 and negative 3. Okay. And our last example, excuse me, is a little bit longer, and we have some multiplication and division. Not a big deal. I'm going to start out and just rewrite it. So I have x squared plus 5x plus 6 over x squared plus 4x plus 4 times 2x minus 3 over x squared minus 9. Ooh, that's the difference of 2 squares. And then I'm making this multiplication, and then I'm going to put this on top. X squared minus x minus 6 over 2x squared plus 7x minus 15. Okay, so we're going to start factoring over here. These ones factor pretty simply. Hopefully we've gotten a hang of these simple ones by this point. What do I multiply to get 6 that I add to get 5? So I can multiply to get 6 with 6 and 1, but that would add to give me 7. Or I would have to subtract. And I don't have anything negative here. So that leaves me with 2 and 3. So I have x plus 2 times x plus 3. And then that's over. Look, this is 4 and this is 4. So I have x plus 2 times x plus 2 times 2x minus 3. I can't factor, but I'm going to leave that there. Over. This is the difference of 2 squares. So I have x plus 3 times x minus 3. And then times, okay, here I'm going to use what I talked about over here, the 6 and, no, sorry, we're not. We're going to use 3 and 2 and use the negative 3 and the positive 2. Because I think we have this on our last one. We factored this. Negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. Okay. Now this one could be a little confusing. It takes a little bit more effort. However, I know when I'm doing a math problem from a math book that typically, like this little guy here that's sitting there all by itself, is going to be involved somehow. I don't know that for sure, but typically if if you have something like this that seems like, oh, I can't factor it, it seems kind of random, I'm going to try to use that here. So I'm going to try to use 2x minus 3, and then I know that this will be an x and a plus. I know that because this is negative, so only one of them can be negative, and it's 2x squared here, so it's 2x times x. Okay, now I need to figure out how to get 7, but I don't have a lot of work to do to check this. There's only one possible thing I could put in to get a 15 here. Negative 3 times 5. So now I check my terms. I have negative 3x and 10x. When I add negative 3x and 10x, I get 7x. Okay, so paying attention to what's in your problem that seems kind of annoying or funky or out of place, it might come in handy later. All right, so if you haven't noticed yet, we have a lot of canceling to do. So, a few things we want to remember. Anything that was in the denominator that's not in the denominator anymore has to be considered for being a possible excluded value. In this problem, I think we can get away not worrying about that too much because we're going to be canceling them out. And remember, if you cancel it out and that term isn't in the denominator anymore, then you'll have to use it to find an excluded value. So let's look and see what happens here. I have x plus 2 over x plus 2. Those cancel. I have x plus 3 over x plus 3. I have 2x minus 3 over 2x minus 3. I have x minus 3 over x minus 3. I have x plus 2 over x plus 2. So if you look, I've canceled out everything. And remember, I can only do this because everything is being multiplied. So each term up here is being multiplied, and each term down here is being multiplied. And that's the only reason I can do this. Okay? That's very important. But I'm left with nothing else. And so I just have this little x plus 5 in the denominator. So I have 1 over x plus 5. So then that means that my excluded values, I know that x plus 3 cannot equal 0. Okay, because I canceled that out here. X minus 3 cannot equal 0 because I canceled that out. X plus 2 cannot equal 0 because I canceled that out. And 2x minus 3 cannot equal 0 because I canceled that out. Everything else, there's not really much else. It's this. This is all that's left that didn't get canceled. And so all a person needs to do is look, and they know that x can't be negative 5. But we need to include all these values that we canceled. So that means that x cannot be negative 3, x cannot be 3, x cannot be negative 2, and x cannot be, if we add 3 to both sides, 2x cannot equal 3, divide both sides by 2, x cannot equal 2/3. So these are my excluded values, and this is my answer. So both parts are a part of your answer. So that one had several. Okay? So that's what this lesson is on. Multiplying, canceling things. It's just division. So you have to remember to change your division multiplication, flip your fraction, and then cancel things after you factor, do all of those things that we've already learned how to do. All right? If you have a question, feel free to FaceTime me. I think on Messenger you can video chat. I think those could be helpful for me to see it. Otherwise, when you ask me a question, if you text me or send me an email, be specific about the section and the problem number, and maybe send me a picture. That's a nice thing with that, is you can take a picture of it and send that to me, and so that I can see where you're at. I can see if there's somewhere you messed up. That will allow you to do more work on your own and understand it better than me giving you the answers. So that's it for this lesson, and I will see you for 11.4. Bye.